Good evening. Welcome back to my channel called Mental. Today I'm going to continue a Python course. I'm following a Python course in the Kaggle website, and there is there are 7 modules. I've completed so far 3 modules, and yesterday I've done the theory for the 4th module, and today I'm going to complete the actual coding part of the module 4 today. If you can't really hear me properly, I apologize. I think I'm having some issues with the connection. I hope that resolves itself. Okay. Okay, so today I'm going to complete the exercises. Things get more interesting with lists. Just make sure I don't think it's well. Everything's well. So right, so it's better now. So, things get more interesting with the lists. Let's see if you can solve the questions below, and remember to run the following cell first. So I need to run this cell first, which does a setup. Setup complete. Complete the function below according to its docstring. So the docstring is the documentation that we give to the method, this section here. Return the second element of the given list. If the list has no second element, return none. Okay, so this is the list. So I'm going to... So to return the second element of the list, so remember that a list, the indices in the list start with 0 for the first element, then 1 for the second element. So this is what I want, right? But we don't want to return, we don't want to throw an exception if there is no second element. So here it's saying if there is no second element, then return none. So I can easily do a check with another function we learned yesterday, which is len of L is bigger than 1, else none. So to do a return, well, I normally like to have a single exit point, because if you have a single exit point, it's much easier to debug the code if something goes wrong. So in fact, so I can just default it to none, and I can forgo with this extra else statement. And that's it. Done. So let's see if it works. So I made a mistake. I forgot to assign a value to result. That's why it gave me. Yeah. So now it's correct. So just for just to see what the actual solution well, I know that, but I just want to see what the solution was. Okay, they've done exactly something very similar to me. Question 2. You are analyzing sports teams. Members of each team are stored in a list. The coach is the first name in the list. The captain is the second name in the list. And other players are listed after that. These lists are stored in another list, which starts with the best team and proceeds through the list of the worst team last. Complete the function below to select the captain of the worst team. Okay. So right, so let's recap. So this is a list of teams, and each team is a list of elements which contains a coach, the captain, and the other players. And the result so the worst team is the last list in our list. So if I want to get the worst team, I can do teams and -1. So -1 will give me the last team in a list. So now we need to get the captain. Captain is the second element in the list. So I'm going to assume everything is great. So it's telling me it has a structure, right? It has a certain number of elements in a list. So I'm not going to do any checks. So the second element is the captain, and then I just have to return that. Worst team captain. So I'm returning what I think is the answer. And I got it right. So next one. The next question says, the next iteration of Mario Kart will feature an extra infuriating new item, the purple shell. The purple shell. When used, it warps the last place racer into first place and the first place racer into last place. Complete the function below to implement the purple shells effect. Okay. So the races. So we need to swap. So the races are these ones. And I need to swap Luigi with Mario. So very simple. It's always best. Even though I can create some Python code that would get the result. Maybe I could do a very smart code here, but I prefer something that's easy to read. So, okay. So the first place. And then the last place. Yeah. And then we want to swap them, right? So this is a list. So R0 is going to be equal the last place. And then R minus 1 is going to be equal the first place. And there's no okay, that's it. I think I assume it was R, but actually it's races. I was looking at the variable in R in the doc string instead of actually looking at the variable in the method. That's why I got it wrong. Okay, now it's correct. So let's go for question 4. What are the lengths of the following lists? Fill in the variable lengths with your predictions. Try to make a prediction for each list without just calling length on it. So it's telling me not to call length. Put your predictions in a list below. Lengths should contain 4 numbers, and the first being the length of A, the second being the length of B, and so on. Okay, so I think this is just telling me to basically point out how many elements are there in each list. Okay, so length of A is 3. Length of B, 1 and 2. So this is an element and this is an element. They are different types, but they are still only 2. Then the length of C is 0 and the length of D. So you see that, okay, the actual list has 3 elements, but because we are using this notation indicates that I'm going to get all the elements except the first one, which is the one with index 0. So 2 and 3. So 2 elements. And that's it. It should be okay. That's correct. Okay, question number 5. We are using lists to record people who attended our party and what order they arrived in. For example, the following list represents a party with 7 guests, in which Adela showed up first and Ford was the last to arrive. A guest is considered fashionably late if they arrived after at least half of the party's guests. However, they must not be the very last guest. That's taking it too far. In the above example, Mona and Gilbert are the only guests who were fashionably late. Complete the function below, which takes us a list of party attendees as well as a person, and tell us whether that person is fashionably late. Okay, so the definition of being fashionably late is if they're basically at the second bottom of the list. So the list itself is in the order of arrival. And in this case, there's like how many elements? 1, 2, 3, 4, 5, 6, 7. So you are basically in the second half if you are, if it's so this is a half. I would say this is the second half. So 7 divided by 2 is 3.5. Then we round it to 4. That's it. Okay. Okay, let's get the length of the number of attendees. So okay, so we need to divide it by 2. So I'm trying to find the first position of the second half of the list. So that would be number of attendees divided by 2. And then, which we need to make sure it's we need to round it. So it's I'm taking the coordinates dash a relative position of the guest that arrived. In this case, name, I should be referring to the variable, and then I'm returning. So his position should be greater or equal. I don't think I even have to round it. Greater or equal than the position of second half. So, of course, but they also can't be the last one. Okay, this is not. So for example, 3.5, we need to do an index. So do I just... So it's, the index is based on 0, right? So I need to add 1 just to make sure everything is in the same way, counted in the same way. So it has to be, can't be last. So it has to be. Okay. So I managed to find a method. Okay. So if it's position 1, it should return false. 1 is not bigger than 3.5, so if it's position 2, okay, position 4. So the 3.5. 0, 1, 2, 3. So it doesn't consider someone fashionably late if it's in position 4. After. So if someone's in the middle, then they don't arrive after. They're basically just within the first half. So if in that case I need to round it down, right? So round. So okay, instead of bigger than equal, I need to return that. This one should return false. So I'm rounding, and I think by default it runs up. Okay, number of digits. Zero. Okay, so I got it right. So I needed to round it. Round the number up so that because I'm dividing the list by half. So a list of 7, for example, is 3.5. If you divide by half, then you round it. So it gives you 4. So if someone is to be considered part of the second half of the list, they need to be above the position 4. And that's what I've done here. And that's it. Done. Let me see if there's a smarter solution to this problem. Okay, I did put print statements. I did make it more readable. But it's the same type of solution. The difference is they used zero-based indexing. So if they've added -1 here, I have added +1. So that's the difference. Okay, so it's done. I've completed the last part of the module 4. And I'm delighted. So tomorrow, I think I've completed it, right? So I don't have to come back to it. So tomorrow I'm going to go to module 5. You can expect me at the same hour, 9:30 London time. I don't know what's going on. Thank you so much. Have a great evening, and yeah, see you tomorrow.